Hey guys, sorry for the delay in starting the next session. This is our second session where Deepanshu is going to talk about how we can start with Cosmos SDK and learn to code on Cosmos. Over to Deepanshu, who is the CTO for Persistence.
Yeah, thanks, Manav. Hi guys, thanks for joining in today. So I'm Deepanshu. I work as a CTO at Persistence, and I'm a co-founder at Cosmos India too. So today's session, I'll try to cover the basic stuff about development with Cosmos SDK. In general, the majority of the developers I meet, who are into blockchain development are into Ethereum and Solidity smart contract development. So switching for that paradigm to Cosmos SDK can be a bit of a challenge from the thought process, the mindset change perspective. So I'll try to disambiguate between these two technologies and other technologies as well, like the blockchain 1.0, 2.0, 3.0. And I would have wanted to give you guys a little hands-on session, but since this is a webinar, I think it will be difficult to follow along while looking at the video. So I'll be glad to have the hands-on session on how to host a validator, not a validator, a full node. Becoming a validator requires someone to delegate to you, and how to host your own chain, and then make a simple application, make a module with using Cosmos SDK.
Sorry to trouble you. Your screen has frozen, so nobody can see while you have shared anything or not. So can you just check that?
Oh no, I've not shared anything right now.
Okay.
Yes, but is it fine now?
No, it's
am I audible?
Yeah, you're audible, but your screen is frozen, so we can only hear you but not see you, like what you're saying.
Okay. Anyways, I'll just speak in this session. I'll do the hands-on session later on in the private chat groups.
Yeah, you can turn off your video and just share your screen so that people can actually just look at whatever you want to showcase them. That will be easier.
Sure. I'll do that. Okay. I'll do that later. Yeah, okay. All right. Yes. Switch off the video in that scenario. Yeah. So to tell you a little bit about, to give you a little bit about the background about blockchain 1.0, 2.0, and 3.0. So blockchain 1.0 was Bitcoin. So it has only one functionality right now, which is the token transfer. There's a UTXO transfer transactions, and if you wanted to build a new application using the Bitcoin code, you'll have to fork the code and build in your transactions. So not much. It was the whole blockchain, the whole code was not designed to have new applications on top of it, but just one use case. It uses a proof of work consensus. So proof of work, as you guys would have known by now, is a little heavy on the electricity consumption side, since it is competitive hash mining. All the millions of systems in the world, they try to compete to solve one hash problem, and only one system is able, or one pool is able to figure out that hash problem, and the rest of the computation that happens, it goes to waste. So Bitcoin right now is the 34th. If it were a nation, it would be the 34th largest nation in terms of power consumption. Its power consumption is much bigger than a lot of very developed countries too. So in progression to blockchain 1.0 was blockchain 2.0, which was Ethereum. So what Ethereum says is it's the world's computer. So there's one chain that's running. There are a bunch of miners which are running proof of work consensus. On top there is the EVM, Ethereum virtual machine. It's like a container where people can plug in the bytes of their code and run that code. So like technically any application that you can think of, you don't have to worry about hosting your own validators or miners. You just plug in your code, and people who want to use it just pay the gas fees for running that metered EVM machine. But this particular scenario did not allow for sovereign chains. So if you can imagine a business that would want to run an application that utilizes Ethereum, the public chain, their transactions going through will depend on the rest of the transactions that are queued up in the mempool, and the gas fees will have to be competitive enough for the transaction to get mined. And the enterprises, the organizations in general would not exactly know what would be their exact transaction fees for processing these transactions in the future, because the token is volatile. On top, they could not even be sure about the rates at which these transactions would be processed at. So this calls for the concept of sovereign chains, which is basically what blockchain 3.0 is. So what blockchain 3.0 says is you can build the blockchains that have functionalities that are decently separated from the rest of the chains, but they have interoperability among themselves. And by default, blockchain 3.0, majority of them utilize a different kind of consensus mechanism, which is proof of stake. So like Bitcoin blockchain 1.0 depend on very specific hash computation. So it utilizes, so people have now started using specific computers that are very good at guessing those hash problems. Those are called like ASIC computers, ASIC miners. Blockchain 2.0, it's a little more general purpose computation that happens on top also. So but it's still the hash problem that needs to be solved. So people utilize very expensive graphic card based mining equipments. But with the POS, it's the stake that you have in the chain that gives you the right to mine the next block, and it's not competitive. So if there are 15 validators that have to mine the next block, all the validators know which one is the next validator that will be mining the block, and rest of them would not be spending energy or computation trying to figure out the hash problem that has no effective useful output. And if you get incentivized for mining a block as usual, and if you were to go Byzantine or if you were to act maliciously, your stake in the chain will be slashed. So that's how POS works. Because of this properties of POS not having to depend on competitive mining, you can literally run a Cosmos-based Tendermint application on a piece of hardware that's as small as a Raspberry Pi. It's not necessary to spend like a couple of $1,000 to run up a complex mining rig. And at the same time, I guess one of the participants, I guess it was Raja, who asked that what if the identity of all the validators is known? Now that's some scenario that is compulsory in case of proof of stake, because all the validators have to present themselves as trustable entities and organizations that people will stake their tokens to. So they have to expose their identities. Some chain might even ask the validators to be KYC AML. So it's kind of like a election scenario, a municipal election scenario, where a bunch of people have tokens and they delegate the responsibility to vote on governance to one representative. So in this scenario, they become the validators. They have to be known. But at the same time, there are mechanisms built in, like utilizing HSMs and sentry nodes that will prevent people from knowing the exact IP and like DDoSing or maybe trying to gain access into the servers. So yeah, that's blockchain 1.0, 2.0, 3.0. We currently are blockchain 3.0 with interoperability and sovereign chains that talk to each other. Some purist blockchain 2.0 purists will say that it should not be compulsory for me to host validators to run my own application or to fork a chain or have 1,500 different kinds of chain for 1,500 applications. But that exactly is the point of blockchain 3.0. All applications having this sovereign chain, which they can run at their specific rates of transaction that they might be involved in the mission critical processes of businesses of, and with stable or stabler token economics and rate of transaction fees and processing. So from the developer's perspective, what's the difference between developing on let's say Ethereum and Cosmos SDK, or let's say Hyperledger? So like that's a question that I initially, when I started my journey into blockchain, I also struggled with, like what's the best platform to like build my base upon. So with Ethereum, it's a brilliant chain to do proof of concepts, and it's a brilliant chain for you to like do projects that you would immediately want to introduce to the world without taking in the effort to actually create your own network of miners, validators, etc. But the flexibility that the smart contracts or Solidity would offer is very limited. It's a Turing complete language, as you guys would know. And the kind of code that you could write with Solidity is very limited. On top, the libraries that might be present for, let's say, if you were to build a new kind of encryption or utilize an arcane kind of encryption, or if you were to consume a API, let's say, or it could be anything. You'd have to, majority of the times, build it on your own, because those libraries are not built for Solidity. There are no libraries like that on Solidity, and even if there were, it would be difficult to run in a container like EVM. So like it's a small project, a POC kind project. It's easy to build on Ethereum and deploy on Ethereum and make it ready. But if you wanted to build a project, if you had an application already, and if you wanted to introduce decentralized, if you wanted to make it a DApp, or if you wanted to build an application that is much more expansive in functionalities and capabilities, like let's say the Cosmos SDK is built on the Golang, so you have access to literally all the libraries that come with Go, the Go ecosystem, and you can use any of those in your blockchain DApp, blockchain based DApp. If you wanted to build a game, if you wanted to build a OS, the possibilities are limitless. Of course, the rate at which these operations will be done is still limited by the rate at which the validators come to consensus to. Right now, it's around 5 to 7 seconds for Cosmos, which is still huge, and the TPS can go up to 8,000 with TPOS. So other functionalities, other things. So if you were to build an application on Cosmos SDK, you'll have to run up your own chain. You'll have to go out and get validators, or go out and ask other people or big validators to start validating for you to run a chain. If you wanted to like test it out, you can run your own chain with single validator node too. But yes, there is no pre-made chain that you can directly plug your application into and will start working. So being a part of Cosmos ecosystem does not imply that you can plug your application into the Cosmos blockchain and it would immediately start working. Being a part of Cosmos ecosystem or the persistence ecosystem implies you'll have to build an application which will have its own chain, which will connect to the Cosmos blockchain or the persistence blockchain and have transactions that can be routed through these hubs and have interoperability with the rest of the ecosystem. So how do we achieve this interoperability? So as you guys would know about projects like Polkadot and Cosmos, these are the two DPoS-based blockchain 3.0 projects that are working on interoperability. With Cosmos, it's called IBC protocol. That's the inter-blockchain communication protocol. So it borrows heavily from the internet protocol to exchange messages right now, and these messages could be anything. It does not necessarily have to be token transfer or NFT or RFP transfer. It could be any kind of token transfer, message transfer. The same goes with the ICMP with Polkadot, which is in interchain message transfer protocol. So these protocol are agnostic to the chain. It's not necessary that ICMP or IBC will just work with one variety of chain. These protocols are agnostic to the underlying SDK or underlying chain. These protocols work irrespective of who implement the specs. So that's how you create sovereign chain that have their own chain, that have interoperability with the rest of the ecosystem. And then comes the concept of shared security. So let's say you're running your application on Ethereum. Now there are like thousands of validators that are running, that are ensuring the security of your chain. But what if you bring up your own chain that just has like 4 or 5 validators that can be like attacked or targeted, and they can be like singled out, or they themselves might form a consortium or a group of their own and try to mess with your chain? What happens then? So there are mechanisms also to tackle those. Those are called this. That problem is called the shared security problem. As in, if you wanted to increase the rate at which your blockchain is processing application transactions, you split up your blockchain into shards or zones. In the case of Cosmos, so Ethereum 2.0 is also trying to do that. But each shard or each zone will consist of a subset of the total number of validators that are present. So let's say if Ethereum has 100 validators, Ethereum 2.0 will split Ethereum chain into 10 shards, which will have 10 validators each. But since these 10 validators, it's just 10 validators validating at a shard level, to make the chain Byzantine, let's say if the criteria is one third has to go Byzantine for the like chain to go Byzantine. In that scenario, only you need to corrupt only 3 validators or miners in the shard for you to compromise one shard. Now let's say, but if there were 100 validators running, you'll have to compromise 33, one third of all the validators to compromise that particular chain or that particular set of transactions. So that's a problem which is called shared security, and there are solutions for that. So with IBC, what happens is the hub chain, the chains track the block headers, the state of the chain that they're connected to, and if there is any Byzantine activities that happens on the sub chain, it could be reported on the hub chain and disincentivized there. So what that technically means is, if you have a Cosmos hub or Persistence hub, and if you were to build a zone that works under Cosmos or Persistence hub, as long as it's part of the one hub, the security of the overall security of your zone is ensured by the hub. There are validators, there are miners running on top of the hub that will keep on looking at your small custom built zone, let's say, which is running with 4 validators, and make sure that it does not misbehave. If it misbehaves, then that particular behavior is disincentivized, or that particular transaction that were incorrectly done to be rolled back and like restarted from a particular state, or some scenario like that. So there are mechanisms like ZK proofs, general purpose ZK proofs, which is a bit in the future, and block header tracking, well, consensus tracking. Then you have a fisherman model, which I guess Asmodat will talk about in depth. So yes, so that's how the overall problem is solved. And yes, discussing a little bit further about Cosmos SDK and what does an SDK imply. Like, you don't hear about a Ethereum SDK or a Solidity SDK. What does a Cosmos SDK mean? So the way a Cosmos application works is you have an app, you have the application and the consensus and networking layer. These are three different layers one has got to build when you're building a blockchain application, right? And building the networking and the consensus layer are generally the most difficult part of building out a blockchain, because that is the place which requires a lot of testing. You need a lot of nodes and you need a lot of scenarios to figure out what scenarios will fail. So what Cosmos does, what Tendermint does, is it abstracts away the networking and peer-to-peer and consensus layer into one engine, the consensus engine, which is the Tendermint engine. The Tendermint engine forms a set of nodes that come in synchrony with each other. The engine takes care of consensus. The engine takes care of voting power. The engine takes care of peer-to-peer communication and networking. You do not have to worry about that when you're building your application. Now, this Tendermint engine, it exposes three interfaces as check.tx, commit.tx, and deliver.tx interfaces. If your application, whatever it may be, if it could be a game, it could be a mobile application, it could be a chat application, irrespective, if your application implements these three interfaces, then your application is basically a DApp. It starts utilizing the Tendermint consensus engine as the consensus mechanism to come to synchrony about the state of your application with the rest of the other nodes running your application. So this makes it super easy. So the way Ethereum solves the problem is you have one place you can plug in your code to make it work, to make it a DApp. Here, you build an application and then make it implement the three interface, and it becomes a distributed application. So there's a much greater scope of flexibility that you can experience with this kind of scenario. Like, what kind of applications could be built on top of the Tendermint consensus engine on these three interfaces? There are n number of applications that could be built. One of those applications is the Cosmos Gaea chain applications, which uses all the modules present in the Cosmos SDK. So Cosmos SDK has modules that take care of token transfer, the bank module that take care of your wallet, the auth module that take care of the distribution, the slashing, the governance. So all these modules, when put together and run in one application, becomes the current Cosmos chain that we see, the Gaea chain. If you wanted to pick out modules that you do not want to use, let's say you do not want to have a token transfer in your chain, you just want to run your chain for the sake of it, you can do that. If you wanted to take out, let's say, the slashing module, you do not want any validator to be slashed, the distribution module, you do not want rewards to be distributed, you can take out those modules. You can add your own modules too. So like the Persistence SDK. So Persistent SDK extends the module that are already present on the Cosmos SDK module, the basic modules like the send coin, the governance, all the necessary modules that are required to run a DPoS chain, a delegated proof of stake chain, and then adds more modules like the NFT non-fungible token module, or the refunds token module, or the escrow module, or the negotiation module, and so on and so forth. So that's I guess someone was asking, why build your own SDK? For interoperability's sake, you have to at least implement the most basic modules that will be offered by Cosmos SDK. As long as you are doing that, you have interoperability with the rest of the Cosmos ecosystem. And then on top, let's say there are modules that are very specific to your use case, or that are specific to one industry's use case, you can build your own SDK. You can go ahead and do that. And since this is an open source community, there's an open source project. It's also possible for you that you have one application in mind that you want to build. You can pick and choose from all the modules that the community has built on in different projects, like a Kiara project, or the Iris project, or the Cosmos project or Persistence project. You can pick and choose the modules, import them in your project, stitch them all together, and you have your own application ready without you even having to worry about implementing the base functionalities yourself. So that's the main benefit of using Cosmos SDK to build applications on top of Ethereum. If you would ask about, let's say, Hyperledger, why not build your application on top of Hyperledger? So Hyperledger, as is in general conventional way, won't be called a blockchain as is. It will be called a DLT, distributed ledger technology, because it's a proof of authority. You mine a transaction, you get an ability to put in a transaction because you have the authority to do so. There's no game theory there. There's no incentivization, disincentivization. There's no token economics that's present in Hyperledger. So, and there are applications out there which require the consortium chains, which do not require token economics, which do not require auditability or public exposure of the state of the chain. So those applications could be built using Hyperledger. The POC kind of application could be built using Ethereum. An expansive application could be built using, let's say, Cosmos SDK. So it depends on your use case, depend on what is it that you are trying to build. Yes, so that's about Cosmos SDK. On top, in the backroom sessions, I can show you how to run a node, because that is something that you generally do not have to take care of when you're let's say running an Ethereum application. You do not have to worry about running your own chain, right? So it's very straightforward. It's very easy. It does not require any special hardware like a graphics card or an ASIC miner. You just have to pull the code, the Gaea code, for example, if you're trying to participate in the current Cosmos chain.
Deepanshu, if you're showing the code, it'll be nice if you can share your screen and everybody can, have a look at it while you're doing it.
Okay, sure. I think, yeah. So generally use Linux, but since the majority of the people I talk to, they are utilizing Windows. So today I switched to this Windows scenario for the screen share. Okay, what's this?
We cannot see your screen.
In the meantime, on this new Windows, it's the thing. Yeah. Okay. Can you see it now?
No. Yes, now we can see it.
No? Okay.
We can see it.
Great. So yes, I'll carry on. Okay. Yes. I think this taking some SVS code is taking some time to load up on this Windows machine. Anyways, since till the time it loads up, I will carry on explaining how this application, let's say, works. Yeah, looks like it's here. So in general, whenever you've got to implement a transaction, how does a transaction look like? The transaction looks as simple as this. let's say you wanted to build a transaction that changes a key, so it will look like this method chain key. For you to have a transaction, for you to call a message a transaction, it will have to implement, if you're doing it utilizing the Cosmos SDK, it will have to implement this interface called the message interface. So if you're implementing the message interface, you'll have to implement 4 functions. The get sign bytes. The get sign bytes will deterministically convert your object into a JSON object and convert it or into a set of bytes that will remain the same irrespective of how you were to marshal them, and give them out as an output as an array of bytes that you can sign. Other one is the get signers. So of all the messages, of all the parameters in the message, you'll have to pick one parameter which will be the address of the person signing it. So that's the get sign byte, as the get sign byte, get signers. So by default, all the transactions on the Cosmos SDK, they allow for multiple signers, so you can call them, all the transactions could be multi-sig transactions. The other two function that you'll have to implement is the type, which will give the module name or the path through which you'll be routed to when you send the message. And the other one is validate basic. So validate basic, you can put in basic validations like calculate the invariance, or see if the format of the, let's say if you're using a string input, if it's correct or not, so on and so forth. So once you have defined your message, once you have an idea of how you're gonna like what your incoming request will look like, what your transaction will look like, then you'll have to define the method that will be handling your message. So if for a module, there could be like multiple 5-6 messages that are being routed to this particular module. So the handler method, it takes care of like switching the message type into the method that will be executing the transaction from this, or changing the state from this particular message. So in this scenario, you can see that the type message is being switched, and if it's then it will go to the handle method change key. Now this will take you to a method that will be in a keeper. The keeper is where your state is, the state manipulation is handled. In this scenario, like you can see, the set public key is the method that will be present in the keeper that is handling the message change state. So this is the message, the handler, the keeper. These are what you'll have to implement at the blockchain end to implement a transaction. For you to have a client's end implementation, you'll have to implement CLI endpoint, a command line interface endpoint, if that is what you foresee you utilizing, a command line interface, and which will in Cosmos SDK uses the Cobra library to take in inputs. So it looks something like this. So this is the account balance CLI endpoint. Yes. And then you can also implement a REST endpoint. So the REST endpoint will, like, you can expose your transactions through a light client as REST, as a REST endpoint, and anyone willing to utilize, your transaction, blockchain transactions, any applications that would want to use your transactions will just have to consume this REST API endpoint. So in this scenario, it's the query endpoint. So its endpoint looks like this. You have a get method with account / the address, and this particular method handles this query and like routes it to the blockchain and gets the state from the blockchain. So that's about how to create a transaction. Now a transaction will sit in a module. So this particular transaction is sitting in the auth module. So the module will have its own types. Like let's say this particular module has its own type called the account type. So you'll have to define a structure that your module will utilize. So auth module manipulates the account structure. So account structure interface will look like this. Let's say it has a get and set address, get and set public key, get and set account number, get and set sequence, and get and set coins. So that's how an account interface will look like. Now there will be a base implementation of this interface. So this is a base implementation which has the parameters like address, coins, public key, account number, sequence. So if you wanted to, you can like utilizing any of the OOPS concept. You can have any like a hierarchy of classes and objects being implemented and being manipulated. So you can have like as your course OOPS course will tell you, like a car interface which can have a base implementation like a persistent car, and then you can have parameters around it and define. If you are implementing these methods, the interface methods, your base implementation will work, and you can manipulate this structure in your KB store. So there is a KB store called key value store, which is like the database which the keeper manipulates. So all these transactions together will will make your module. So what are the different modules that we have here? We have the auth module, which manipulates the account. We have the bank module, which handles all the coin transfer transaction. There's a fee distribution module, which handles distributing all the fees from the block mining and the staking. We have the IBC module that handles all the IBC KB store, which publishes messages from one chain for the other chain to see and like translate it to a transaction that they would do on their own chain. And you have the slashing module in case of there's a malicious activity, there's like a governance transaction saying that this person should be slashed, or if there is an event that happened that merits slashing, this module is the one that will have hooks into the app that will automatically lead to a slashing. And then we have the staking module, which will handle all the stake transactions and the unstaking transactions or redelegation transactions, etc. The time period. So all these modules have a bunch of have a subspace on top of the KB store, a subspace where you store the params or parameters related to these modules. So like the stake module. The stake module could say that once you have staked your tokens to a validator, you'll have to wait for 21 days if you are undelegating for the validator. Now this is a parameter. And what's a fun thing about Cosmos SDK is through governance, it allows for you to change these parameters on runtime. So let's say majority of the validators or the stakeholders or any person who holds a token on the chain gets a vote. If a proposal is passed that the time it should take for the undelegation to happen to be reduced from 21 to let's say 1 day, or to be increased from 21 days to let's say 365 days. And if majority of the token holders or the stakeholders in the chain vote for it, that parameter on runtime changes on the chain. So that's a fun, cool feature that exists. So yes, how do you include all these modules in your application? So you'll have to build another project. So the SDK project will just give you the modules. Let's consider the Gaea project. So Gaea project is the one that will give you the let's open a new window for the Gaea project. So the Gaea project is the most basis application that you can build. It does not have its own module. It just implements all the modules that the Cosmos SDK offers, and that's the most basic application you can build. And that particular application is live right now and running on a network called the. I'll show you that network too. So Big Dipper Cosmos Explorer. Yeah. So let's look at this Explorer too to give you an idea about how the chain runs. In the meantime, this is.
Deepanshu, can you also start concluding the session once you're done with this?
In the meantime, also, would you guys questions? Yes.
Yeah, guys, any questions you have for Deepanshu?
Taking some time. You guys can start asking questions. I can like extend this session into the more like specific way if you guys have any question that I could handle right now. Just being mindful of the time.
So we have Bharat writing on the chat, any good links for learning how to do it?
Has also given up on me.
All right, Deepanshu, there's a question from Bharat. He's asking any good links for learning how to develop applications using the Cosmos SDK.
Yes.
So Raja has a question for you. Bharat's question was answered by Tushar.
Yeah, all this code, is it available on GitHub or is it something proprietary, private? Whatever the code shown, is that available on the GitHub?
What's the question?
Raja, all the code is open source, so it will be available.
Okay, thank you.
Yes, I cannot see.
It's okay. Got.
So yeah, Raja. So if
All right. Any other questions that you have for Deepanshu? All right, Deepanshu, you want to showcase anything else?
So what I will do now is like I'll go to the chat rooms and like take that this discussion and like the specific hands-on there, not to waste like the people who wouldn't be interested in developing, and we can take the discussion over there. This sounds good.
Perfect. That will be great. All right. Thank you, Deepanshu. So I'll be ending this session and we'll be starting with the next session. Thank you.
All right. Thank you, guys. Thank you for your time.
Thank you. Hey guys, our next session is by Asmodat, who is one of the initial members, community members of Cosmos. He runs a company called Gaea, and he will be talking about Cosmos and his journey till now. Over to you, Asmodat.
Hello, everyone. Hope everyone can hear me loud and clear. My name is Matteo. I'm a CTO at KiraCore. My background is I'm ex-Barclays R&D. Then I was an infra for Settle Finance. It's American-based company, and then I was a product manager for BT.com, which is Switzerland-based, and now I'm working on the project called Kira, which is an interchain exchange. I have a presentation for you. So I will share a screen right now so you can see it better. Let's jump right in. All right. So this presentation will be a sort of an infomercial. You will learn a few things from here. From me, you will learn like how in the past the centralized exchange ecosystem looked like, how the infrastructure looked like, how it's going to look during the new paradigm, during the proof of stake era. What are the main issues with proof of stake currently, and how Kira fits into the ecosystem, why will you need Kira, and where is the opportunity in here. What is the current decentralized ecosystem dilemma is that the users currently using centralized exchanges, they are not going to onboard on the decentralized ones unless we can provide them three main points, which are the security, access, and throughput and latency. Unless they have those three issues are solved for them, they are not going to come into the decentralized ecosystem and straight there rather than on centralized exchanges, because the throughput and latency on Ethereum is so high, and they don't feel it as a like real alternative to the centralized exchanges. So if we will have a look how in the past the decentralized exchanges look like, this is what you will see. You have three layers. Currently, you have three layers. You have a public network, which is a public network, which is, for example, Ethereum, Bitcoin, or some other network, which is a settlement layer. Basically, it's a place where transactions are usually settled. Most of the logic, however, occurs on the private servers. Here you have a backend, which is an API that queries the public network, sees the transactions on chain, and aggregates the data and displays it to the user by hosting some UI server frontend that then user accesses. And thanks to this frontend, he can propagate transactions to the blockchain. So we can see that the majority of architecture, in case of decentralized exchanges in the past, were almost completely centralized. Why? Because although you had this decentralized element, which was the blockchain application running somewhere and holding the state, the owner of the server that aggregated the state of the blockchain was not does not hold your funds. However, this if the access to the server is cut off for you, then of course you cannot execute transactions anymore. You would have to directly communicate with the blockchain. You would have to execute transactions, execute orders through the smart contract, which is extremely difficult for the users. And for this reason, this kind of architecture is legacy architecture. We will not see in the next paradigm. So the problem of proof of stake. Problems of proof of stake because if we were in the past in a proof of work ecosystem with Ethereum, with smart contracts, where miners were executing those smart contracts. The problem in the past was that other applications were throttling your applications. So the here came the proof of stake paradigm, and it proposed the idea that your blockchain application can be run independently. Like if Cosmos SDK, as Deepanshu and Tushar they mentioned before, like instead of being throttled by other applications running on your chain, you can create your own blockchain application. You can have your own validator set. However, securing the proof of stake blockchain application, if you are not using the SDK like persistence, if you are not using KYC validator set like with persistence, and you are trying to create proof of stake application, you will have three major problems, which is nothing at stake problem, death spiral problem, and security leaks. And in order to mitigate those issues, you either use SDK like persistence, or you will have to come with specific solutions to those issues, and you will very likely get a centralized exchange, which I will try to explain a little bit later. Like, so what is nothing at stake problem? Let's go through those points. Nothing at stake problem is a problem where the assets you create that's supposed to secure your proof of stake network, that the asset that can be slashed if something goes wrong, if there is no real value behind them, if you just printed a token, then the security of your blockchain is not really there. You cannot have permissionless validators, and you cannot let anyone become a validator just because they have tokens. Why? Because those tokens can be traded on centralized exchanges, and if the centralized exchange gets hacked, right, then the security of your proof of stake blockchain can be compromised, and that's the security risk. And that spiral is a result of that centralized exchange where your token trade being hacked can cause your validator set not to be able to even sustain the operation of your proof of stake blockchain. That's why the SDKs, that's why permissioned validator sets are currently the only secure way to deploy your proof of stake blockchain. That's why I'm a bigger fan of persistence here. And here with Kira, I'll present to you few of the solutions that we are working on, so that over time we can go to this full decentralized ecosystem where you can deploy your proof of stake network with your own token, and you will be able to secure it. And here is where the Kira exchange comes into place. So what are the solutions that we are proposing here? There are three things that we are trying to solve. It's nothing at stake solution, for which we are using the multi-bonded proof of stake. The Tushar Deepanshu explained how the bonded proof of stake works, but you can stake some asset, let's say atoms or dot tokens on Polkadot, on some other assets. Delegated proof, that's the delegated proof of stake, and if something goes wrong, if your validator misbehaves, the assets are slashed. Here we are using the multi-bonded proof of stake, so we are not basing our security on just on one of our tokens, one of like some artificial token. We are using many different tokens to secure the blockchain. We will allow people to stake Bitcoin, Ethereum, and other assets in order to make sure that there is value at stake, that the validators to which the assets are delegated, if they misbehave, that's the real value is being slashed. Permissionless and trustless access to the market is a solution that we are working on for the death spiral problem. And the death spiral problem, as I mentioned before, occurs where you deploy your new proof of stake blockchain, and you need an exchange on which your assets can trade securely. If you don't have access to the interchain exchange, like Kira, you will be at disadvantage that the only place where your assets can trade is a centralized exchange. If your assets can trade only on the uncentralized exchange, and this centralized exchange get hacked, then your security of your network, of your proof of stake network, suddenly becomes a security of the proof authority validators, basically, that operates your blockchain, because there is no value at stake anymore. So it becomes a proof of authority blockchain suddenly. And we solve yet another problem, which is solution to the security leak, which is liquidity and staking optimizations, which we are working on, and those are the staking derivatives, so that you will be able to trade assets that are already on stake, which is another issue that centralized exchanges are the core of, where they allow you to trade assets that are staked at the same time. We've seen not just a few weeks ago, we just seen a first attack of the sort where the blockchain was the assets on the exchanges were used to vote on proposals on the blockchain. So because the exchanges hold insane amounts of assets and control them, they can influence the governance. So like this is the architecture overview that we are proposing for the novel state-of-the-art interchain of blockchain, Internet of Blockchain kind of applications. This is how the architecture will look like now. As you see, there is no more any centralized part in here, except the public repositories where everyone can have a look at the code, where everyone can get client application, fetch it, and use it. So currently in the new architecture, we see also 3 layers. It's a settlement layer, execution layer, and a client layer. Deepanshu, I think, explained before what is a hub-spoke architecture. So here we will be using a very similar kind of architecture. We'll have a hub, which is a settlement layer where all the transactions are being settled and the value can be stored coming from the other blockchains, thanks to IBC protocol like Cosmos, Bitcoin, Ethereum, Polkadot, Persistence, and other internet blockchains. The value can be directly trustlessly transferred to the hub, where the state, where the governance occurs, a settlement occurs, and then the assets can be sent to the exchange zones, to the shards where the blockchain application actually does the order matching. So the order matching no longer occurs on some centralized server as it was happening in the past in case of like case of the DEXs on Ethereum. You no longer have some centralized server that matching order. You can have an order matching on chain, so it's transparent, and you can have client application that can directly communicate with the blockchain application thanks to the light clients. So inside your browser, you can have a client application that directly talks to the full nodes, directly talks to the blockchain application. So there is no this middleman. You no longer go to some centralized server in order to see what's happening on the blockchain. You can directly, from within your browser, touch the blockchain application. There is no more downtime in such case. If someone tries to attack the centralized entity hosting this UI server that shows you information, there you will continue to have access. You will be able to access any full node in the network instead of just relying on this single provider. Multi-bonded proof of stake. As I said before, like the major innovation that we are trying to work on here is consensus that will allow to ensure that there is a real value at stake. We are trying to do it thanks to the IBC protocol, thanks to by allowing other assets to be staked. So not only our own asset that we will create, that will be Kira token kex, we will be able to stake Ethereum, Ether, and other assets. And in exchange for staking those assets, you will be able to earn our token kex that will later allow you to claim revenue from the exchange operation. And this multi-bonded proof of stake consensus will be possible to be reused by other projects. So this is something that the ecosystem will be able to grow upon and will be able to benefit as well. What we're looking also at is staking derivatives, so that the Bitcoin that you are depositing and staking, you will be also able to trade. So that centralized exchanges that currently allow you to do so, like Binance, for example, where you can stake atoms, and they have full control over your asset, you'll be able to do so on the decentralized exchange. You'll be able to stake your asset securely, earn revenues from staking your asset, and trade them at the same time. So thanks to this mechanism, you will have we create a sort of a liquidity pool, because the more assets at stake, the more of the assets that can be used to trade, the higher the liquidity. Usually, when you trade proof of stake tokens, you only trade the assets that are unbounded, that don't earn rewards. With multi-bonded proof of stake and staking derivatives, you will be able to stake and trade at the same time. And with the multi-bonded proof of stake, we are looking at permissioned validator set. In case of persistence, you had the validator set that is KYC. In case of Kira multi-bonded proof of stake, you can have anonymous validators, but they will be only able to join your network if the governance approves of them. Why is that? Because there cannot be a mechanism in proof of stake networks where you steal someone else's token and you become a validator. If you have permissionless validator set, this is a huge hole in which we don't want to fall into, and we have to secure millions, potentially billions of dollars at stake. Also, what's interesting in the multi-bonded proof of stake, the voting power of each validator is going to be equal. If there is going to be any kind of misbehavior coming from one of the validators, then those validators will be kicked out of the validator set. And still, it's a Byzantine fault tolerance consensus engine, so 2/3 of the validators will be securing the network. Another innovation we are working on is an enlightened democracy. And enlightened democracy is an idea that allows the chain conscious members to control the network. So as I mentioned before in the previous slide, we have a permission validator set. So in order to have a permission validator set and allow other people to join the network and allow the network to come to the consensus and secure it, we need a strong governance set. We have to bootstrap our network security in order, we have to go from more centralized to more decentralized, instead of trying to be completely decentralized by distributing a token and hoping that sheer value at stake and that sheer user due diligence that they will not be sending asset to centralized exchange and that they will not be hacked. We don't want to take any chances here. So how the enlightened democracy solves it? How can we implement a governance that's secure for everyone? First, we start with a sort of technocracy. So initial validator sets becomes a governance set. And those initial validator sets elects council members, elects people who are not validators but are chain conscious actors that can make decisions. Then those chain conscious actors can make proposals, can vote on proposals, and can help the network to evolve. This way, the governance set extends continuously, its growth, instead of shrinks by some people accumulating a proof of stake token and suddenly gaining more voting power. That's why I think that due to the previously mentioned issues, that the way to go is permissioned validator sets, just like Persistence is doing, rather than permissionless validator sets, just like Polkadot is doing, or most of other proof of stake network are trying to they are going for. Permissionless access to the market. it's where you will see why Kira fits into this ecosystem. You will see, thanks to the permissionless market access, is a way to not only being able to bring your token to life and be able to trade it. It's a way for you, for your new blockchain application, for your new proof of stake network, to join the system and be able to secure yourself. Because as I mentioned before, if you allow your token to be traded on centralized exchange, if your token gets gets hacked on the centralized exchange and some person accumulates huge amount of it, suddenly this can cause a death spiral. So for this reason, any project that joins the interchain will need a permissionless access to the market, will need a decentralized exchange where they can bring their tokens, where they can stake it, where they can trade it securely without Kira, without anyone controlling their assets. So permissionless access to the market in case of Kira is going to work in a way that instead of you having to pay some, ransom to Binance, right, you will put your assets at stake to vouch that the market is legit. If are assets at stake, then the asset can trade against any other asset that you will choose to vouch for. So then the trading can occur as long as there are assets at stake vouching for this market, and if there's something wrong going on with the market, for example, asset you listed was not real asset, was some fake token, then those assets that are locked can be used to reimburse the traders that were harmed by this. So non-custodial trading. So maybe I'll explain a little bit what's a non-custodial trading that I mentioned before. So non-custodial trading means that when you trade your asset, the platform that you trade your asset on doesn't have control of your asset, and that's Kira. We will be integrating with ICMP. It's currently renamed to XCMP, Interchain Messaging Passing Polkadot, Interchain Blockchain Communication, IBC, and other interchain communication protocols. So you'll be able to bring your existing tokens originating from other networks like Ethereum, Bitcoin, Tezos, EOS, and other chains. You'll be able to inject them into the interchain ecosystem, into the Cosmos ecosystem or Polkadot ecosystem, and you'll be able to transfer them into Kira Exchange, and in a way that we do not control your funds. So all the assets deposited to the Kira Exchange, we don't control. You are the one controlling your own assets. Thanks to those interchain protocols, and you'll be able to trade foreign assets. So that's basically a forex. You'll be able to trade Bitcoin for Ethereum without having to trust any custodian issuing you wrapped Bitcoin, like it's happening right now on Ethereum, right? So the Bitcoin that you have on Ethereum and other assets, they are wrapped assets. They are not real, trustless assets. You have to trust this dude that holds those Bitcoins in his wallet, that once you send him back your wrapped Bitcoin, you will get back your real Bitcoin. Like in case of IBC protocols, in case of interchain ecosystem, you will not have to trust anyone. And finally, we are trying to solve the throughput and latency issues, and this is going to occur through the hub-spoke architecture. Just as Deepanshu and Tushar mentioned before, you have a settlement layer and you have zones or a parachains in which execution occurs. So you have the settlement layer where majority of asset is secured, and then you have the zones where the execution of certain time important application is occurring, where in our case the order books are going to be sharded, so you'll be able to trade on multiple different zones rather than trading on single blockchain that could be throttled. So those are the dedicated trading exchange zones, and we are employing here the fisherman approach to security. similar as it's done with Polkadot, because I don't know if you know, like I think there were a few questions about how does the Cosmos and Polkadot differ, how they are different. There was a mention that the Polkadot has shard security, and that's a problem. Why is the problem? Is because if the hub in case of Cosmos is called it's called a relay chain, if you are a zone, and if you are this parachain or parathread, and you are using security of this relay chain, and the relay chain fails, why would the relay chain fail? Because, for example, there's a bug in the application, or because there is a death spiral, because it's a permission validator set in case of Polkadot. So if the issue like this happens and your parachain fails, then the security of your zone is also compromised. However, there is a way to mitigate this problem. And if you are in Cosmos ecosystem, you can first of all deploy your own blockchain that has its own validator set. And second of all, you can use fisherman approach to security. It means that anyone can re-execute that the state that is state transitions that are occurring on the zones, and report back to the settlement layer, oh, that the fault occurred. And then the validators on the smaller zone can be slashed instead of entire parachain failing and the fault propagating through entire ecosystem. So you can visit us at kirax.com. Our Telegram is Kira InterX. So I think now it's the time to ask some questions if there are any. I will stop sharing my screen.
Any questions for Asmodat, guys?
If you want to ask about Polkadot, about Kira, about maybe the nothing at stake problem, or honeypot attacks, death spiral problem, security leaks, or anything that's technical related, you can also throw questions at me here.
No questions? All right. Okay. I think that's what everybody is there. This was too much information for them. I think so. They like to sink in before they like to ask any more questions from you. All right. Thanks a lot. All right. Bharat has a question for you. Nothing at stake.
Okay. Nothing at stake. Okay. Can everyone hear me? I guess yes.
Yes.
And nothing at stake is not a problem when random verifiable functions are used to select validators. First of all, like, what's the problem with nothing at stake problem, right? Is that the security of your blockchain is, as Deepanshu and Tushar mentions, is the security of your validators, right? So even if you detect that the application was not executed correctly, like just not even mentioning that this will take immense computational power to do, right? So you are not going to provide centralized exchange experience. So because the security of your blockchain is really security of your validator set, that those people, they can just change kind of application that they are running, and it doesn't matter if there is value at stake, if there is verifiable functions, they will change entire blockchain application with your verifiable functions running on top of them, and they will run totally different application. So from the perspective of people interfacing, from the client perspective, the entire blockchain can be totally rearranged. Like any state can be rolled back in any way they want, because this will be like a hard fork here. So you will need another validator set. It will take months to roll back from issue like this. So at the end of the day, the nothing at stake problem is a problem where it's not just about securing, but it's about that the proof of stake itself is not going to be secured with just someone printing the tokens. If you just print a token and you just hope that if this there is this my token that I print at stake, so if it gets there's are so much incentive not to misbehave, so no one will do like. That's not usually the case. That's we already seen like the attacks that are happening on the proof of stake blockchains, where funds deposited on centralized exchange are being used to vote. So if someone hacks your asset, like even if someone hacks your asset and you have permissionless validator set, right? It doesn't matter how you choose the validator, right? If there is majority of the people having power in your network, they can run any code they want, and you will not be able to do anything about it. That's why we need persistence, that we need permission validator sets. That's how the business can secure their own applications without having really to trust the stake itself. There have to be multiple layers, in my opinion.
All right. Okay. Any more questions? I think so. That's it. Thanks a lot, Asmodat, for the insightful information regarding Cosmos and about your product. Thank you. Thank you. We'll now be next session is a panel discussion, so I'll be starting with that. Thank you.
Bye-bye.
Hey guys, this is our final session where we have Jeffery Hu.
Hi everyone. I'm Jeffery Hu from AirSnet, and today I want to introduce AirSnet to all of you. And first of all, I want to have a brief introduction for myself. And I'm a director of research in AirSnet. And before that, I worked in hobby research as a chief analyst. And before that, I directed several blockchain projects in China. So I really love the crypto, really love the blockchain. So I want to communicate with all of you. So okay. So next. So next, I will go into today's main topic of AirSnet. So the AirSnet is the self-evolutionary interchain service hub for the business applications. But so you may have one question. So what is AirSnet on Earth? So actually, this question about 1 year ago, especially in China, very often people ask us, what is the AirSnet and what is the relationship between the AirSnet and the Cosmos, the Airs Hub and the Cosmos Hub. So here is a chart to illustrate that the Cosmos has its open architecture to support multi-hub and multi-zones. So Airs Hub is another Cosmos Hub to provide the enchanted security, performance, also diverse use case for the interchain ecosystems. So, in one sentence, the AirSnet is an interchain service hub focusing more on the distributed business applications. And we built many important features to facilitate that. So here's a chart to demonstrate that. In my opinions, because the Cosmos actually provided 3 great innovations to our industry, including the Tendermint, including the Cosmos SDK, as well as the IBC, the interchain communication protocols. So the Cosmos SDK is very modular, and you can use it to build your own blockchains. I think Tusha and Deepanshu just explained that Cosmos SDK in details. So I want to repeat more on the Cosmos SDK, and we'll just emphasize on what we have built upon that. And on this chart, we can see that these functions actually are different layers built by AirSnet to support the distributed applications. The first one is one of the most important features of us is the on-chain governance, as well as the parameter governance and upgrade governance. So based on governance, we built many application support modules like multi-assets, iService, CoinSwaps, and oracles. With these functions, we can both support DeFi applications on the public blockchain and the enterprises applications on the like permission blockchains, private blockchain, even centralized systems. So the first module I want to introduce is the on-chain governance I just mentioned before. So that's sorry, that's where I think that's why we call AirSnet is self-evolutionary, because we can smoothly upgrade our mainnet by community voting. The smooth means you don't need to purge old data or upgrade with a hard fork, but instead mainnet can be upgraded by the on-chain governance, so by the community votings. So last year we did this for 2 times. The first case came in last August. Actually, it's also the first case for the B-Post network. And we also did it on the last November for the second upgrade. So by the on-chain governance, we got many mainnet features. For the first version for the first upgrade, we got multi-asset management, random number generator, and others things like the multi-sign, key stores, and some module upgrade. And for example, the multi-asset is very useful when the IBC is ready for the other assets on the other chains, and like the atomic swap, which is known as HTLC, can support cross-chain asset swap before the IBC. And also we are building some more functions to support DeFi applications like CoinSwap. You can see it is very similar to the Uniswap, which you can build your own DEX on the blockchain to support the decentralized tradings. Also, we got some new exciting features that are coming. We are developing now, like oracles. Oracles, you can provide some data source from the off chains, like the trading prices and the random numbers and so on. And another important function we are building now is we want to refactor the iService to provide more powerful functions. The Oracle function actually we also built by the help of the new version of iService. And so you may wonder, what is iService? iService module actually allows the external resources to be integrated into the blockchain. So iService is named by the Ares service. It is intended to be the bridge of the blockchain world and the traditional world. So right now you can build the iService provider using the service interface provided by the Ares Hub to link the public blockchains like Cosmos Hub and some consortium blockchains, and even some centralized systems. You can see it is like the service hub where applications and blockchains can exchange their services. So that will become a service market or data market if you can just involve more functions to that. So iService, actually you can see it. It's more function like the application layer to the blockchains, but we can go down deeper than between that. It is the IBC. So the IBC, we also contributed some code to the IBCs. So last year we contributed to the ICS20 modules, which is the token transfer modules. Also, we developed a demo for it during the San Francisco Blockchain Week last year. You can also find this demo on our Twitter if you like. So for this year, we also have some exciting news. I think one of the most recent news is our first anniversary on the March the 1st. We summarized some our validators you can see here of our mainnet, some of which also being upstreamed to the Cosmos SDK. Also, we have built our technical communities to about 700 developers now, and 46 of which has also contributed their code to our mainnet. So, another news I want to show you is that about 1 or 2 weeks ago, we open sourced our permissioned blockchain or consented blockchain products. It's called Areta. Areta is have many advanced features compared with other permissioned blockchain like Fabric, because it has more powerful features. Like comes from the public blockchain, like the tendermint consensus, like the IBC, like the iService I mentioned before. But also we got more functions over that, like the privacy protecting data sharing, like the flexible digital asset modeling exchange. So also we can provide some big data analysis for it on the Areta. This is a permissioned blockchain product. So the last thing I want to share with you today is that we also run the community of Cosmos China, just like Tushar running the Cosmos India. So for the Cosmos China community, we moderated daily technical discussions and translated and wrote dozens of articles and that help the spreading of Cosmos in China. Here is some data for the Cosmos China. And last year, we also held some events for the Cosmos, both offline and online. For the Cosmos community in China, we held these meetups. So as an ending for today's speaking, we are very open to many kinds of collaborations for all of you guys here today. And so please feel free to contact us through these channels, emails or Twitter and media, whatever. So just keep with us. And so this is my speaking. And if you have some questions, please tell me.
Yes, Tushar.
Hi, Jeff.
Hi.
Just for the interest of all the attendees, because not too many know about what is happening in China. If you could give a broad overview of, what is the blockchain ecosystem like in China, and approximately how large do you think the community is, and what are they excited about, these days?
Oh, yeah, great questions. In my opinion, the blockchain industry in China actually can mainly divided to two big parts. The first part might be the public blockchain ecosystem that many people can trading their crypto assets through the exchanges. You can see many exchanges actually they have many users and their workers in China, like Huobi, like OKEX, and like Binance. So most of their workers and users are in China now. So this is one for the public blockchain. And also we many teams in China now are running their crypto projects like us. We are running the AirSnet now by our core dev team called Bianjie. So actually, there's another ecosystem in China. So they are we call it the blockchain projects teams. So they just want to build their own blockchains. So I think there's another one for the public blockchains, and also another big part of the China's the industry is for the permissioned blockchain. That is, you can see that the blockchain without the crypto assets. Many company, even the big company, actually run this kind of business now, like the Baidu, like the Ali, like the Tencent, they are also running their own permission blockchain projects now for mainly for the governments, mainly for the other big companies clients now. So they want to build this the permission blockchains for some like the projects to help the real industry for that. So as a result, as a co-dev team of the ArisNet, Bianjie also do list two kinds of business now. We also run the ArisNet now, and we also build products for the Ariton now. So we just want to do list two kinds of industry in China. So this is, I think, the main situation in China now.
Thank you.
Yeah, thank you.
Jeffrey, there is another question from the audience that says, could you explain a bit more about how an RNG has been implemented on or for the blockchain? Jeffrey, did you get my question? Jeffrey? Hello?
So do we have more questions?
I think there's one more question about in the chat, actually. If you, on the right side, if you click on chat, there is one. Yeah.
But I can't see the question now.
The question is, how do you, how is the RNG or random number generator implemented for IrisNet?
Sorry, you mean the number?
Random number generator, RNG.
Oh, random number generator.
Yeah.
Oh, yeah. That's a feature we introduced last year. Actually, this is what currently we introduced the random number by some on-chain parameters now. But for the next version of our mainnet, I think we will expect it to introduce some more features or mechanisms of this random generator on-chain, because we can introduce some random numbers from the off-chains. So we can introduce random numbers by some off-chain random generator now, and to combine with the on-chain and off-chains random number to give a more robust random number. So actually, you can check for our documents on the internet to see that functions. You can use that. Actually, we have used that for some lottery draws to last year to pick some lucky users of ArisNet to give some airdrop to them.
Any more questions for Jeffrey? All right, Jeffrey, I think so. That's it. Thanks a lot for sharing about Iris Network. And thank you for being a part and talking to the community in India.
And do we have more questions? Sorry, I can't see the questions on the red panel. I can't see any messages there.
No, it's okay. That's it, I think. There are no more questions.
No more questions.
Okay,
Yeah.
I see.
Thank you so much, Jeff.
Yeah, thank you.
Thank you, Jeff.
Thank you, guys.
Thank you.
Right.
All right. Thank you, everyone, for being a part of this session. And I will be now ending the session, and you all can go to the social lounge and interact with each other and, network with people out here. Thanks a lot for being a part of our first virtual meetup. Thank you. And thank you to the AirMeet team for helping us and supporting us to doing this great event. And it's a great platform that you guys are making. Thanks a lot. Thank you.